Good morning, students. This video is purely for the B.Sc Third year student. So, dear friends, we are meeting after a very long time of interval. Actually, this paper number 19 we have already covered before the lockdown was imposed by the government. But after that one, the examinations are to be started from the 17th of the March. But unfortunately, during this one period, the coronavirus pandemics have been started and the entire country is locked down, and we all are for lockdown at our respective homes, and examinations are also postponed. But from the last 2 days, some news channels and print media are also showing that the examinations of the 6 semesters are particularly going to start from the month of July. But it is a very long period, since from the March to July, the portion which we have seen, you can understand or you can recap your mind. So I have decided that I should interact with the third year student. I will not take each and every article of the paper number 19, but just I will try to recap the portion which we have seen. So dear student, as you know that this paper number 19 which I have taught during this academic year 2019-2020, we are having the 4 chapters. This paper name is Atomic, Molecular Physics and Lasers. These four chapters are there. First one is the atomic model, second one is the vector atom model, third one is the molecular spectra, and fourth one is the laser. So in the first chapter, that is atomic model, there are the different articles: atomic model of the Thomson and Rutherford scattering, classic atomic model, Bohr's model of the hydrogen atom, success and failure of the Bohr's model, characteristic X-ray spectra, atomic number, and atomic excitation by the electron. I am not going in detail of this each and every article belonging to from this particular atomic model, but just within the half an hour or just within the 20 minutes, I will go to summarize the entire first chapter, so that you can recall your memory and you will understand that what we have done, so that you can go through the notes. All the notes and the PDF files of the notes are already uploaded on the Moodle of our college. You please go through your Moodle account, open this and take the notes. And just in this video, I will try to recall you that what we have seen and what are the important articles of this particular chapter from the examination of point of view, which are going to be in the month of July. And particularly examination will be on the MCQs, that is multiple choice questions. So this my video will be helpful for you to go to this examination. Now, piece of evidence that scientists in 1900 to indicate that what is the atom? What about the atom? Atom is considered to be very small kind of particle, each belonging to the distinct chemical element. Atom and electromagnetic phenomena are intimately related. The problem of valence, certain element combined with some element, but not with the others. The discoveries of the radioactivity of X-ray and all these are about the electron. J.J. Thomson has given his idea about the atom, that what is the atom? Atom किसका बना होता है, कैसा होता है, उसने प्रूव किया. उसने एक लंबी थ्योरी की. इब्तिदा में उसने अपनी थ्योरी में बताया कि atom can be any element made up of very tiny negative particles. बताया कि बहुत छोटे-छोटे negative particles होते हैं एटम में. ये थॉमसन का इब्तिदाई जो है नजरिया है, जिसमें वो कहता है कि all atoms must contain these negative particles. The atom did not have a net negative charge, so there must be balancing the negative charge. There may be some positively charged particles. According to J.J. Thomson, the structure of the atom is just like as you can see in the figure. This is the Thomson model. He thought that atom is a spherical object that has electron inside the homogeneous jelly-like material and having the diameter of 10⁻⁻10 meter. He thought that he had a massive charge particle distribution cancels the electrons. Thomson model is sometimes also called as plum pudding model. According to Thomson, the atomic structure is as shown in the figure. Now, what is the postulates of the atomic models theory? Thomson had theory that says the rays emitted from the electron gun were inseparable from the latent charge. Thomson had another theory that says the carried a negative charge. Thomson's third theory was tried to work out the nature of the particles. They were too small to have their masses and the charge and calculate directly. First, he found out the experimental setup which was given by the scientist J.J. Thomson in order to determine or in order to confirm this atomic model which he has given is of this type, that his first experiment was built with the cathode ray tube with a metal cylinder at the end. The cylinder had two slits in it leading to electrometers. One is the anode, another is the cathode, and when the potential difference is given between the anode and cathode, a particular type of particles are moving from the positive negative charge to the positive charge and current is flowing. This is the experimental setup. The second experimental cathode ray tube which was designed by the scientist J.J. Thomson. Now this is the experimental third experiment of the J.J. Thomson. Now Thomson's plug pudding model of atom has the positive charge separately uniformly through the square in the size with electrons embedded in the uniform background. In Thomson view, when the atoms are heated, the electrons could vibrate about their equilibrium position and thus producing the electromagnetic radiation. Now after this J.J. Thomson model, the Rutherford has given his another model, because in the J.J. Thomson model there are some drawbacks, and therefore Rutherford has proposed that the atom has positively charged core nucleus surrounded by the negative electrons. That means according first time the idea of nucleus at the center was given by the scientist Rutherford, and in the Rutherford ideas that in the center there is the positive core, and around the positive core the electrons are revolving in its orbit just like this, which you can see in the figure. And mathematically he has also proved that how his idea is of the atom is there. And after the Rutherford, this is you can see in this slide that how the positive core is there and electrons are moving around the nucleus. This is the nucleus at the center. These are the electrons which we have shown in the red, and this is the orbit of the electrons. So electrons are moving around the nucleus in this orbit like this. This is it look like a star. Tari ki tarah ye nazar aa raha hai. You can see this is the energy level, and these orbits they are also called as the energy level, because electrons which are revolving in the different orbits have a particular type of energy. In the first orbit, energy is different. In the second orbit, energy is different, and therefore these orbits are also known as energy levels. See here, this is the motion of the electron in the orbit. So after the Rutherford model, the most important model which is uniformly accepted till today, it is the Bohr's theory, or it is the Bohr's model. According to the Bohr's model, the nucleus is present in the center. It is a very short part, very small, spherical nature, and around the nucleus, different electrons are moving in a circular orbit just like this. And these orbits are also of increasing energy, as you can see in the figure. See here, this is the photon is emitted with the energy is equal to h nu or hf. You can see the Bohr's model of the atom, like many ideas in the history of science, was at first prompted and later partially discovered by the experimentation. The unsatisfactory model for the hydrogen atom, according to the classical theory, light should be emitted as the electrons, circles of the nucleus, loss of energy would cause the electron to be drawn closer to the nucleus and eventually spiral too. We can see here, this is the central nucleus, and around the nucleus, the electrons are moving in the different orbits. See here, this is the path of the electron. So you can see with this of this slide. And this is the quantum mechanical model which describes the electronic structure. As you can in chemistry, you can see electrons are present in the different orbit and the numbers are different. It's 1s2, 2s2, 2p6, 2p2, 2p6, and so on. The model can be viewed in this way. Atom is mostly empty space. Two regions. One is the proton, neutrons, which are in the one thing, that is the nucleus, and second one is the electron cloud, where is the region where you might find an electron. So Bohr's formula based on this postulate that the area of stationary orbits and total energy of the electron in the orbit. And with the help of this one, that according to the electrostatic force of attraction, using this particular formula, and using the different postulates of the Bohr's theory, we can determine the energy of the electron in a particular orbit, and simultaneously we can also determine the radius of each orbit in the particular atomic model. So you see here, this is the radius of the first orbit is 0.053 nanometer. This is called as the Bohr's radius, and accordingly by changing the value of m, we can determine the radius of the successive orbit. Now total energy of the electron. The total energy of the electron in any particular orbit is nothing but it is the sum of the kinetic energy and potential energy. We know that there are the two types of energy. Therefore, electrons are also, when they are revolving in the nucleus, around the nucleus in the orbit, they possess the two types of energy. One it is the kinetic energy, another is the potential energy. And combination of these two types of energy is nothing but total energy of the electron in that particular orbit. So according to the electrostatic formula, potential energy of the electron is this much, that is Z dr is equal to minus Z e square 4 pi epsilon naught r. Kinetic energy is one half mv square, as you know. But in this case, mv square means Ze is 8 pi epsilon naught r. And putting these values, we found that value of energy that has come is En is equals to minus, this is a symbol, m e raised to 4 Z square upon 8 epsilon naught square n square h square. And the value, as from the formula you can see, as the value of n increases, En also, as energy also increases, and the outer orbit have greater energy than inner orbit. That means from this formula 8, we can confirm that as the orbit goes on increasing, or the number of orbit goes on increasing, or in the outermost orbit, the energy of the electron goes on increasing. That means the electrons which are in the inner orbit, they possess the less energy in comparison of the electrons which are present in the outermost orbit. So Bohr interpretation of the hydrogen atom can also be seen by carrying out the difference between the energy of the electrons in the two successive orbits, that is En2 minus En1 divided by h, where h is the Planck's constant. And here you can see that V bar which I am showing, it is the wave number. Wave number of the radiation is nothing but it is the reciprocal of wavelength, that is lambda in the vacuum, and it gives the number of waves contained in unit length in the vacuum. V is equal to 1 upon lambda, as you know, V is equal to V upon C. So these are the different spectral series of the hydrogen atom, Lehman series. In the Lehman series, what happens? Electron jumps from the second to third, that is orbit to the first orbit. From second, third to first orbit. That means jumping of the electron takes place from second orbit, third orbit, fourth orbit to the first orbit. And therefore, the previous formula V bar is equals to R1 upon 1 square minus 1 upon R variance is equal to 2, 3, 4, 5 is the Lehman series. For the Bohr series, electron jumps from the outer orbit to a second, it is third, from third to second, fourth to second, fifth to second, and so on. So depending upon the jumping of the electron from the successive second, third, fourth, and fifth orbit, there are the different series. There is a Lehman series, Bohr series, Paschen series, bracket series, Clifford series, and energy. And if you want to draw this energy level diagram for this different type of series, you can see that at the top of the corner of this particular slide, this is the energy level diagram showing the different series in which the jumping of the electron is taking place from the different energy level to second to first, third to second, fourth to so, and so on. And they are systematically showing that how these are the different series can be shown in this way. You can draw the energy level diagram in this way also, or you can also draw the energy level diagram by drawing the horizontal lines and showing the energy levels. It is n is equal to 1, is equal to 2, is equal to 3, and so on. And jumping of the electron for the Lehman series from second, third, fourth, fifth to first, for third to sixth, and so on. In this way, you can. These are two also. Previous one also. This is also the energy level diagram. It is in a circular way, and this is the horizontal lines you can draw, and this is also the energy level diagram. So in the examination, if this question is asked to draw the energy level diagram and to show the hydrogen ion series, or if you ask that show the different type of series, draw the energy level diagram, then you have to draw such type of energy level diagram. This can be also the Bohr series for hydrogen atom. A line spectrum is there. So Bohr theory of hydrogen atom can be used in the different way. Today in the quantum series, it is most important. These are the some notes which I want to share with you. This slide I am sharing with you because in detail about this Bohr's model we have already interacted with you. But now these days it is not possible for us to interact with you. So just with this, sharing with you this slide with the help of this video, I am trying to recall your memory so that you can go back to your previous portion which we have seen. This is once again I am showing you the energy level diagram for the hydrogen atom. See here, these are the absorption and emission spectra. These are the different absorption and emission spectra for the hydrogen. This is Coulombic interaction in the hydrogen atom. This is Coulomb law, the calculation for the Bohr expression, that how the radius and energy can be calculated. So with this one, I hope that you might have got the very much idea about the portion which we have seen in the first chapter, that is the atomic model. And this is the first chapter of our paper number 19. It is the vector atom, atomic model. Then the second chapter is the vector atom model. This is the first chapter, atomic model. In which three important models are given. One is the J.J. Thomson model, found by the Rutherford model, and later one is the Bohr's model or Bohr's atomic theory, which consisting of most important portion, that is the energy difference, the determination of energy, determining the radius of the Bohr orbit, different formulae for that one, and this is the successive success and failures of the Bohr's model. That Bohr's model was a great step for the new quantum theory, but it had some limitations. What are the limitations of the Bohr theory? It works only to the single electron atom, could not account for the intensity of the fine structure of the spectral line, could not explain the binding of the atoms into the molecules. Continuous X-ray spectrum can also be explained with the help of the Bohr's model. So with these three ideas of this one, I hope that you might have got the better idea of this particular chapter, which I want to express here. So with this one, I am not going in detail as I have already told you. So friends, thank you for joining me for this lecture. In the next video, I will try to explain about the second chapter of this particular paper number 19, that is the vector atom model. Thank you. Have a nice time ahead. घर में रहिए, खुश रहिए, इत्मीनान से रहिए. Thank you.